Hello everyone, welcome to TEQIP GATE classes, an initiative by TEQIP Faculties. My name is Nihit. I have completed my MTech from Temporary Cover Digital Communication. I have qualified the GATE exam 6 times. At present, I am working as an assistant professor at IISc IITs, Madhya Pradesh. I have more than 4 years teaching experience. So this is the second lecture of random variable random process, and in last session yesterday we have discussed some. We just go through some basics of probability, and we did the we did some numericals, and just go through with what is the probability and all things. Okay, now we just further move uh, in this progression. We just move further. Okay, so okay. Yesterday we have leave this question. So we discussed this question today. Uh, so the question is that the given block diagram shown below. This is a block diagram. Probability of failure of machines A, B, and C. It means the if machine A, B, and C will fail, the probability of this event is 0.4, 0.6, and 0.5 respectively. So determine the probability of transmission of information from X to Y. From X to Y. So we have to transmit the information from X to Y. So and the A, B, C, all three machines are mutually independent. There is no dependency of any one machine to other one. So we have to find the probability or transmission, proper transmission of our message from X to Y. So here we can see that if how many possible ways uh, the information can transmit from X to Y. You can see here if either this way, first one, either this way or either this way, second way, because it is parallel connection, or you can say it is addition, or you can also say it is a union. Union means either this or either first one or second one. So okay, so you can see here that if first uh, okay, this is the first assembly line, this first assembly line, this is second assembly line. Okay, if that message signal or message can be transmitted from X to Y, either from first or from second, or both first and second, from first and second. ओके या तो पहला फर्स्ट असेंबली लाइन वर्क करेगी या तो दूसरी करेगी. ओके, या फिर दोनों कर सकते हैं. दोनों के तीनों केसेस से in all three cases our information can transmit from X to Y, and we have to given the probability of failure of machines A, B, and C. Okay, so you can see here in the first assembly line, if A and B they are connected in cascading, so if either of them, any of them, A and B, will fail, then no transmission occur from the first assembly line. It means again if A will fail but B is in working condition, no transmission from the first portion. If A is working but B will fail, so also in this case no transmission possible from the first assembly line. In the second assembly line there is a C. If C will fail, so no transmission possible from second assembly line. That's why we have to take the, you can say here that कि A intersection B, it means they have to work together. They must work together, or union. It means either this first one, either second one. It means union मतलब C. Union C. It means either A and B work together, or C will work alone. But A and B have to work together. So we have to take the how many number of possible combination are there, so that we can transmit the information from X to Y. So just we write the behavior A, B, and C. So you can see here. Let's say I denote zero. I denote zero as a failure and one as a success. You can say machine is properly working, or success one means sorry, zero means failure, means machine is failed, it's not in working condition. One means success, means our machine is in working condition. So the number of possible combinations are 8. So 0 0 0 0 0 1 0 1 0 0 1 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. These are 8 possible cases, and you can see here the A and B should in order to transmit the information from X to Y, A and B both have to work together. That's why they cannot do either A alone or either B alone, cannot fails together. Sorry, either A alone or either B alone cannot fails, and together they are also not. They are not together. They both machines A and B not should not go to failure. So that's why the most preferable condition is, and C is alone. If C is alone working and A and B are either of them both fail, or both of them A and B will fail. So in that time C is working. So also in this case transmission can take place from X to Y. So our favorable condition is such like that. This is not a favorable condition. It means the A will fail. If A will fail, then first assembly not working, in not working condition. C is fail, so no transmission occur. In second one, the A and B both will fail, but C is in working. So in this case, transmission can possible. A and B, if A is fail, A will fail, and B is in working condition, but C is not working. So also in this case, transmission was possible. So you can say that okay, this is the favorable condition. This is not a favorable condition. This is the favorable condition. This is also the favorable condition. It means that A and B both are in working condition, but C is not working. But in this case also, the transmission can take place from X to Y. And in this last one case, this one, A, B, and C, all three are in working condition. That's why transmission occurs. So the probability of transmission from X to Y is P equal to, what is the probability? And all three are independent. So it means we have to multiply the probability of each event. So we have to multiply. So okay. So the favorable cases are 0 0 1, then 0 1 1, then 1 0 1, then 1 1 0, then 1 So this means that 0 0, it means A and B will fail. So probability of failure of A into probability of failure of B into the success of machine C in working condition. So C bar equal to 1 minus 0.5 equal to 0.5. So that's why I write here 0.5. Okay, then is a ठीक है. either this or this, ठीक है, or this or this or this. It means either this process will work, 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 or either this process will work to make transmission from X to Y. And that's why I at the end we will add all of these things. So the probability of 0 double 1 is 0.4 multiply 0.4. Here 0.4 is because for the success of machine B. That's why 1 minus 0.6, 1 minus 0.6 equal to 0.4 into 0.5. Then 0.6 multiply 0.6 multiply 0.5. Then 0.6 multiply 0.4 multiply 0.5, and then 0.6 multiply 0.4 multiply 0.5. The values are, you can solve. So 0.12 and 0.08 and 0.18, then 0.42, then 0.12. After adding all of them, 0.62. So the you can see here the probability of transmission from information from X to Y, we get 0.62. Okay, I hope you can this question will you can understand. ये question आपको समझ आया होगा. So now we will move from our next topic. The topic is conditional probability. Conditional probability. So you can say here that what is the condition probability? If the condition probability of event A, given that event B is already occurred, it means the condition probabilities are those in this probability. If there is a dependency of one event to another event, the occurrence of a event is depends on some another event. For example, uh, there are three companies X, Y, and Z. They are supplying uh, mobile chips or mobile circuit chips to the something company X, any one of company. There is some probability that some defective piece produced by X, Y, and Z individually and independently. There is and all three companies supplies the electronic chips to company C. Okay, so okay, one day company C find some defective chips, electronic chips, some defective electronic chips. So you have to find if company C receives some like defective items. So company has to find from which this item belongs to which company. So you can say that the item supplied by X, Y, and Z company, but C received that and C received some amount of defective items. So we have to find the probability. So the event of finding defective chips in the C is depending on manufacturing defective chips by X, Y, and Z. That's why the C finds a defective chips. The probability of finding defective chips at the company C is depends upon the defective chips manufactured by X, Y, and Z. So these events are so the events occur in company C is depends upon the events which are already occur in event X, Y, and Z. So this condition probability is based on to find the probability of event if another one whose dependent first event is already occurred. Okay. So the condition we denoted condition probability as it means that the probability of event A given that event B is already occurred. So we can write here as the PA given B equal to PA intersection B upon PB, and the PB should be given 0. It is called a joint. It is called intersection. Or you can say common thing, common between A and A and B. Okay. So condition probability is that A given probability of A given B equal to PA intersection B upon PB. So then P, when you can see here PA intersection B is the joint probability of A and B. So joint probability of A and B. Now you similarly P A given B, you can find PB given A. It means that the probability of event B if 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 A is already occurs. A is already occurs. So okay, what is has also A has already occurred. A has already occurred. So okay. Similarly, the probability event B if the A is already occurred. And probability of A should be greater than 0. It should not less than 0. The probability is never get negative value, never contain negative value. Okay. Now you have to find the condition for you have to find the joint probability of event A and B. So from the equation 1 and 2, from equation 1 and 2 you can find that the joint probability of A intersection B is this and this. They are come from equation 1 and 2. Now the next term is Bayes rule. Next term is Bayes rule. We should say that in the event the condition probability of event A is given that the B is already equal to its probability is equal to this form B A equal to condition probability of event B if A is already occurred, and this is the condition, this is the probability of event A and this is the probability of event B. Okay, this thing is come from equation 3. This comes from equation 3. So it is very important, or it's very important definition in the context of condition probability. Okay. Next, independent events. Independent events, the occurrence of one event does not affect the occurrence of another event. So it is a counterpart of condition probability. For example, probability of A event A given that B is already occurred. If A and B both are independent event, so occurrence of A does not affect the occurrence of B, or occurrence of B does not affect the occurrence of A. That's why, and this is the probability of event. This is the probability of event A if B is already occurred, but this is the probability of A. That's why PA given B. If A and B are independent, then it is PA. This is PA. That's why I wrote here. If the two events A and B are said to be statically independent if PA given B equal to PA and PB given A equal to PB. Okay. If we write the together information, joint, it means this is called joint information. Joint information. It's called joint information of A and B. If A and B are mutually independent, so that's why we can write here is as PA into PB, or okay, if you can write in terms of condition probability, that's why PA given B into PB equal to PA given B equal to क्या है PA होगा. This is PA into PB. So you can find also from then you can also derive this formula with the help of condition probability. Okay, if there is ample amount of events, there are so many events. So there are so many events. Even if A are mutually independent, they are independent. That's why the intersection of AI1 to AK or AN equal to probability of individual events. The probability of joint event A1 to AN is equal to the individual is equal to multiplication of individual event probability. So you have to memorize this thing. Okay. Now the another topic is total probability. The another topic is total probability. Okay. For example, the events A, B, and N are called mutually exclusive. This means it means that no common thing between A, no common thing. Also, no events occurs together. No events will occur together. So that's why we call A and R mutually exclusive. And exhaustive means all we make together. If we merge all events together, it will make the sample space. It will make the sample space. That's why I said here that this is total probability is here. The A1 up to AN are the mutually exclusive because no will occur simultaneously. And no common no common thing occurs or happen in the all events A up to AN. In exhaustive means if we merge all the events, it will make the sample space. Okay. For this, you can understand that B is the event. Let B is the event, an event in sample spaces. सैंपल स्पेस बी मान लीजिए कोई इवेंट. अब थोड़ा इस डायग्राम को देखिए आप, जैसे इस सेक्शन को देखिए. फॉर एग्जांपल दिस इज द सैंपल स्पेस ऑफ ओलंपिक, सैंपल स्पेस of games, Olympic games. Okay. Now let's say the A1 is another. A1 is a type of game. B2 is a type of game. B3 is A3 is a type of another game up to AN. Okay. And this shaded portion, and you can also see here. You can also see here. No portion is common. No any portion is common between A1 and A2. Also, no portion is common in between A2 and A3. It means they all elements are mutually independent. All elements are mutually independent. So let's say A event B is associated with the sample space S. Event B is associated with sample space S. So you can see here this is the shaded portion. This shaded portion is the event B. This is the event B. You can see here that the event B contains some values of all events. मतलब you can आप ऐसा कह सकते हैं कि B जो है वो सब events का कहीं ना कहीं पार्ट है, कहीं ना कहीं पार्ट है. So you can say that this is the Olympic, the sample space of Olympic game, and B is the chance of achieving gold medal. Gold medal. We can say that all this is the sample space of Olympic games. Even if AN are the different Olympic games, and they are mutually exclusive. No event, there is no common thing between any of event, and they are completely they merge together. They will frame the sample space. So B is the event to achieving gold medal. Okay, in our entire Olympic game. So in this even game, there is a possibility of achieving the possibility of achieve or possibility of getting the gold medal also in this also in A2 and this is also in A3 and up to A5. So this is the probability of getting gold medal. Okay. So the complete probability of getting gold medal in all the event, in all the event. So what you have, for example, you have to find. So in this Venn diagram, you have to find the area of. You have to find the complete definition of B. This is B. So what you have done, आपको क्या करना पड़ेगा? You have to if A B in event A1, the B share is some portion. As in event A2, B shares some event, some portion of A2. It means that there is something common. Something is common in between B1, in between the event B and all events. So you can say here that you can, it means total value B equal to probability of B intersection probability of joint probability of B and A1 plus probability of event B or getting gold medal intersection the event probability of event A2 plus up to plus probability of B intersection up to AN. I use intersection because I want to find जो चाहिए the common area. That's why I use here intersection. That's why I cannot use here union because union is the complete portion. Union means complete portion A1 or this B or either both of them. I want to find the this exclusive this area. That's why I use intersection. So this equation can write here like this. Okay. Now you can see this is the joint. This is the joint probability of B and event A. So you can write this as a conditional probability. Okay, as a conditional probability. Now you can you know very well that the probability of event A, joint probability of event A intersection B equal to probability of event 2 is also right as probability of event A given B condition as a conditional probability into probability of event B equal to probability of event B given A into probability of event A. So okay, okay. Now if he wants to find the if to use this equation, I can also write here P A given B equal to P A given B equal to now I am using these two expressions. From these two expression, I will get probability of B given A, probability of A given B equal to probability of B given A into probability of A upon probability of B. Or as in total law of total probability, if I change A as AI, any event A1, A2, A3 up to AN. So probability of event AI given that probability of B. It means for example, this is a football. Means you can say this is a game of shooting. AI is a game of shooting. So occurrence of event occurrence of game of shooting. Given that we can get the gold medal in this. Given that we can get the gold medal in this. So this is like this. So it is from this to this. So B given AI into P A upon PB. What is the value PB? PB is this summation I equal to 1 to N P B given AI into P A. Okay. So you can find the this probability of AI given P just like this. Okay. So here this is this. Now we just we just go through the some numerical form regarding this total probability of okay. In this section, in this question, there are three boxes contained. There are three boxes contained. The boxes are B1. Boxes are B1. Another box is B2. Third one is B3. And they contain some balls. B1 contains 7 red, 3 white ball. B2 contains 3 red, 2 white ball. And B3 contains 4 red ball only. The ball is picked randomly from the one of these balls. A ball is picked randomly from the all three balls. Any of three balls. If the probability you choose three boxes are, it means the selection of boxes are the probability of selection of boxes are half 1 by 3 and 1 by 6. The addition of all three is 1. Then find the probability that the ball is red. Find the probability that the ball is red. Ball is red. So you can see this like that. Okay. This is the complete sample space. Okay, this is box B1, this is box B2, and this is box B3. Okay. Let's say this is the event of getting red ball. This is the event of getting red ball. So as you know that this formula, this is a probability of event B, which is associated with all the events A1 up to AN. That's why where the probability of getting red ball is associated with all event B1, B2, and B3. So what is the probability of getting red ball? So P get red equal to what is the summation PB given A1 into PAI. So it is summation I equal to 1 to 3 because there are three boxes. Probability of getting B when probability of getting red ball from the box 1. So I probability of getting red ball from the BI box and in probability of BI. So it is like that probability of red ball. Okay. If it is selected, if it is fall from box B1 into B1 plus probability of getting red ball from box B2 into probability of selection of box B2. Then probability of red ball from box B3 if and into multiply selection of box B3. So the red ball fall from B1 box. The red ball fall from B1 box. So B1 contains 7 red balls, and the total balls are 10. So probability of getting red ball from the B1 is total balls are 10, and the red is 7. So 7 by 10 multiple. Probability of selecting B1 is equal to 1 by 2. So it is 1 by 2. Bracket plus 10. Red ball from box B2 is equal to in box B2 there is 3 red balls and total balls are 3 plus 2 5. So that is 3 by 5 into B2 is equal to 1 by 3 plus probability of getting red balls. There is only one red ball. Okay. No other ball will exist. So it means one ball will fall. That is 4 balls are there and total balls are 4 balls. Total balls are 4 and all are red. That's why 4 by 4 equal to that is 1. Definitely red ball. Definitely the probability of getting red ball in box 3 B3 is 1. Well, multiply. Then B3 is 1 by 6. So after solving this, you will get 53 by 60. So this is the probability of getting red ball. ठीक है, which is associated with the box B1, B2 and B3. Now the question is that what find the probability that if the appear ball to be red, then what is the probability of getting that was picked from ball B1? It means red ball, this event is occur. It means we can write here as a red R and this P and have to select from B1. So that is B1. That is B1. Okay, that is B1. So this equation is like such like this. This equation is such like this. So is equal to probability of red ball B1 into B1 upon probability of getting red ball. Probability of getting red ball. This is same like this. So if you want to find the probability of getting probability of selection of box B1, if red ball was fall from B1 box, is equal to probability of getting red ball from the box B1 into P B1 upon probability of red ball. So this is the very well this value we have find from the just previous section. So this is 7 by 10 because there are 700 balls, total balls are 10. So the probability of getting red ball from B1 is 7 by 10 and probability of selecting box B1 is 1 by 2. So I write here 1 by 2 upon the probability of getting red ball, which we have find in previous example, that is 43 by 60. So it is equal to 7 by 20 multiplied 60 by 40, that is 21 by 43. Okay. Now the another example, the probability that students knows the answer of multiple choice question is 1 by 3. It means there is a two events. Okay. This no K and this don't know. No, and this is don't know. Okay. And this is event, another event, which is associated with no event or don't know event. The probability that the student knows the answer is MCQ is 1 by 4, 1 by 3. He does not knows the answer, then he may guess. वो guess लगाता है. Then probability of guess is correct is 1 by 4. Then what is the probability that he has answered correctly? So this event, this event which is associated with partially associated with no and don't know event is the probability of getting probability that the answer is correctly. Answer has probability that he has answered correctly. This is the probability of getting answer correct. PC. So you know the for the probability of getting answer correct is PC equal to the probability of that the answer is correct if he knows the answer into probability that he knows the answer. This thing is that the probability that the answer is right if he knows the answer, and the probability that he knows the answer, and the probability that answer will correct if we don't know the answer. If he don't know the answer into probability that he don't know the answer. So you can see here the student knows the answer and the answer will correct. So what is the probability of this? It's always equal to 1 because I know the answer and definitely I will correct it. So the probability of correction is always 1. Multiply the probability that he knows the answer, that is 1 by 3. it is 1 by 3 plus probability that he answer will correct if he does not know the answer. So he does not know the answer, then he will guess the question and the guess will correct, that is 1 by 4 multiply probability that he does not know the answer. The it is a probability that he knows the answer. So what is the probability he doesn't know the answer? That is 1 minus 1 by 3. It is 2 by 3. That is 2 by 3 equal to 1 by 3 plus 2 by 12, or you can say here is 6 by 12 equal to half. The answer will correct. The probability that answer will correct, that is 1 by 2. The three companies X, Y, and Z supplies the computer to a university. Okay, the percentage of computers supplied and probability of those being defective are tabulated below. यहाँ पर ऐसा दे रखा है. These are the percentage of selection of company X, Y, and Z, and these are the probability given. These are the probability which are given that X produce such amount of defective products. Okay, given that a computer defect, given that the university receive a defective product, university receive a defective computer. So what is the probability that was supplied by Y company, that was supplied by Y company. So you can see here that so probability of getting defective item. Probability of getting defective item equal to defective item if it is come from company X into probability of selection of company X plus such like similarly probability of getting defective item from company Y into probability of selection of company Y plus probability of defective item come from company Z and the selection of probability of selection of company Z equal to. So this is the this is the probability of item get defective from company X. This also probability of item getting defect gets probability of item getting defective, probability of getting defective item from company Y and Z, that is 0.01 multiply and this 0.6, 0.3 and 0.1. So this is 0.6 plus 0.02 multiply 0.3 plus 0.1 multiply 0.33. The values for result is 0.015. This is the probability of getting defective item of either from any of company XYZ. Now the defective item probability that defective item was received at university, but is come from, it is supplied by company Y. So probability we have to ask Py given D, Py given D. So this right as the solution is D, probability of getting defective item which has come from company Y into selection of company Y upon probability of getting defective item. Okay, so that is the values are 0.02 multiplied 0.3 upon the value of probability of getting defective item is 0.05. So this is 0.4. Answer is 0.4. Next, now random variables. Now we start our actual topic, that is random variable. I want to suggest you that now you should not go the theory portion of this topic. Just follow rigorously follow the numerical portion of this topic. You don't need to go in depth that what is random variable, how it is used in daily life, because our concern is numerical. So I'm suggesting you that you just follow the numerical. So the what is random variable? The outcome of an random experiment is mapped into some countable numbers, and that set of number is called random variable. For example, you throw a dice. The result outcomes are random, and that outcomes are 1, 2, 3, 4, 5, and 6. A single throw will produce single outcome, and this is random. So we have get such set of values. So this set of value, the set is we assign a variable that is that vary from 1 to 6. This variable, this experiment map into a single variable x. This is called random variable because its values are random in nature, and these values are random values of random variable x. Okay, but you have to understand this. Okay, for example, another example, uh, 2 coins are tossed. 2 coins आपने toss किए. So probability of getting head. So getting head. Getting it. Number of ways of getting it. So 2 coins are tossed. It means what are the possibilities? Either tail head, head tail, or head head. It means and where concern is head. There are 4 possible ways of getting results. So we define random variable x, which denote the number of heads will come in the event of tossing of 2 coins. So in this case, the head number of heads is 0. The first value is 0. Okay, this is a random variable x, and we map this random event, this event toss of 2 coins. We map into a random variable. In this case, number of head occurs is 1, and here 2. The values of random values of random variable x, which denote the results of getting head of 2 coins which are tossed, that contain 3 values 0, 1, 2, 3. So I think you can now you will able to understand what is the random variable, and a certain event, real time event, random event. How can we map into a some set of countable values, and that is called random variable. Okay, these are definitions. You just read this, and nothing is new in this. I just in the very simple way I elaborate all thing in just previous slide. Okay, there are two types of random variables. There are two types of random variable. Random variables. First one is discrete, and another is continuous. First one is discrete, another one is discontinuous. If okay, for example, in last slide here, you can say there is there are random variable x contains x contain 0, 1, 2. So only 3 values. And it does not contain any value 0.01, 0.25, such like that. It contains integers values and some countable in a finite series and in integer form. So the values are not in continuous form. It means it does not contain values between 0 and 1. It only contains 0 and 1. Not does not contain values in between of 0 and 1. That's why it is called discrete. It is called discrete. That's why this end variable is called discrete end variable. This is called discrete end variable. Or if an end variable that contains the values, okay, that contains the values between 1 to 20, any value. It contains the values from 1 to 20, any values, but in a finite, within a finite series. It is called continuous random variable. Okay. So now we first discuss the discrete random variable. We first discuss the discrete random variable. Okay. So first we define the PMF, probability mass function. This is a definition. You can say the identity of a discrete random variable defined by the PMF, probability mass function. Identity, or you can say what is the introduction, it is an identity card. PMF is an identity card of a discrete random variable. The definition is the discrete random variable definition is sustained by the PMF. Okay. Then we write PMF as small p. Here that is random variable, and in the small bracket we show the its random value. We show the random value. Okay. The function px is called the probability mass function या PMF of the discrete random variable x. Okay, these are the certain properties of PMF of a discrete random variable. So I just write three properties of discrete PMF of random variable. But now I want to understand. I have taken. I am going to take some numerical example. So first one is said the a random variable x. I now going to elaborate the first property. A random value will contain some values like 0, 1, or 3, like 2 only. The value is 2. Okay. So regarding the probabilities, x p of 0 is something. The probability regarding random value 1 is p of 1 and p of 2. These all are positive. All are positive and all are less than equal to 1. Less than equal to 1. Or you can say get n equal to 0. Get n equal to 0. They are must positive. It means the probability of getting a certain single random value is never negative. It's always positive. A range of the range of probabilities that probability of that values is 0 to 1. Okay. Another thing is that all the other than this is random variable, it contains the random values 1, 2, 3. Okay. So the probability of other than random values which are not part of random variable x that is the probability of those value probability of get probability of those values random values are 0. For example, if we want the probability of random value 3, which is not part of random variable x, so that probability is 0. Okay, and summation of all probability of all random values is equal to 1. Is equal to 1. So this is the cumulative CDF, cumulative distributive function. CDF, cumulative distribution function. So I will discuss later. First, I want to show some numericals. I want to discuss some numerical with you so you can understand what is the how PMF work and what is PMF. So this question. Okay, this question. Random variable x with PMF given below. ये आपको दे रखा है. This is the PMF of a random variable x is given here. It means this random variable x. These are the random values. These are its random and this respective probabilities. Okay. Then first question is find the value of k. Find the value of k. So you know very well that here the summation of all probabilities of all random values is equal to 1. So that's why you can say that 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k equal to 1. Okay, after solving this, we will get 10k square plus 9k minus 1 equal to 0. After solving this quadratic equation, then we will get minus 1 comma 1 by minus 1 comma 1 by 10. ठीक है. So the value of k equal to 1 by 10. So okay, in this question we have find the value of k. So and B, C, and D. The part of this question we will discuss in the next session. Uh, before before that we will discuss the distribution function of x. Okay. Okay. Thank you.